as you know, this is a trapezoid. You're probably familiar with like what the shape looks like. What makes it a trapezoid is it has one pair of parallel sides. So make a note, one pair of parallel sides. So with a parallelogram, or all the parallelograms, it had like both opposite sides parallel. With a trapezoid, it only has one set of parallel sides. So this side right here is parallel to this right here. And then this is a trapezoid as well. Again, this side is parallel to this one. There's also some vocabulary here. One is the base. So these two parallel sides are called bases. So this is base and base. And then the two that aren't parallel are called legs. So this is a leg and this is a leg. And over here, same thing. This is a base and a base. And then a leg and a leg. Okay, so something that happens because you have these parallel lines. So let me use different colors for So you have these parallel lines right here, parallel line here, and here, and that makes this leg a transversal. So therefore, the angle pairs that you would have with parallel lines and transversals are also present here. So these two angles, this angle right here and this angle, are consecutive interior angles, and they are supplementary. So star plus star equals 180, and then if you're trying to figure out one of these angles, you can just subtract from 180 to find out the other one. Okay, then next, trapezoid's child is called isosceles trapezoid. Isosceles trapezoid. Isosceles, you've seen that word before with triangles, and in triangles it means two of the sides are the same measure. It actually means the same thing with a trapezoid. Isosceles trapezoid has two sides the same measure, and it looks like this. So it's like a perfect trapezoid. In an isosceles trapezoid, the legs are the same measure, so legs are congruent. And then the other thing that happens is the base angles are then congruent. So with this isosceles trapezoid, this angle is the same measure as this one. And then this angle is the same as this one. So base angles are congruent. And one more thing with the diagonals, so just drawing another isosceles trapezoid. Again, isosceles means that these two legs are the same measure. Then the diagonals are congruent as well. Diagonals, let's see if I can spell it. Diagonals are congruent. Okay, one more concept here. And it is mid-segment of a trapezoid. So mid-segment of a trapezoid. Okay, so first of all, what is a mid-segment? So I'm going to quickly draw a trapezoid. Okay, so a mid-segment is when you have a midpoint over here. So I'm going to have the midpoint. Okay. Midpoint here, same measure. And then a midpoint over here, the middle of this segment. So this is the same measure as this. And then connect those midpoints, and that's your mid-segment. This mid-segment is the middle length of the, here, let me show you. Okay, so let's say this is A, and this is B, and this is C. The length of the midsegment is the average of A and B, so you can do A plus B divide by 2 to get the measure of C. So if we're using numbers, let's say A is 2 units long, B is 4 units long, C would be the middle of that, which is 3. Now, depending on the numbers, you might not be able to just see the middle, so you can find the average of those two numbers, 2 plus 4, divide by 2. That would be 6 over 2, which equals 3. So C equals 3. And that's how you'd figure that out. We're going to practice that in the homework, or like the note packet too. Okay. Next, that's it for trapezoid. We're going to move over to kite now. So moving over, you ready for me to move? You're going to yell at me. Okay, kite. Over here. Okay, you're familiar with what a kite looks like most likely, just because in like elementary school and stuff, they really hone in on like the naming the shapes. So here is a kite, as you're familiar with. What makes it a kite is that there are no parallel sides. No parallel sides. Or that's one thing that makes it a kite. Okay, so the trapezoid had one set of parallel sides, parallelogram has 2 sets, and then kite, no sets of parallel sides. And then the other thing that is important is the diagonals here are perpendicular. So diagonals are perpendicular. Okay, what else happens? The consecutive sides are equal. So this length is the same as this length, and then this length is the same as this. And then last but not least, this angle is the same measure as this angle. So one pair of congruent opposite angles. So these angles are equal. And then the other thing we'll see in the practice is since this makes a 90-degree angle, these are all right triangles. And you can use Pythagorean theorem to find lengths here, and we'll see that in the practice. Okay, so that is all for the quadrilateral family tree. I will be checking this like right after the lesson after we're done. So just leave it out. And then also this will be really helpful with Alex this week because there's a lot of like naming shapes and this will help you with that as well. So go ahead and transition to note 7.5 and we will work on that.